Hi, I'm an old guy and I do maths, and I was given this problem a day or so ago and asked if I could figure out the answer, which I think I have, and I thought it was such a good problem that I would make a video about it. So what I'm going to do is I'm going to use the notes that I gave to my pupil and talk my way through them. There's a few pages of them. It's not a particularly easy problem, but I think it's one well worth looking at. So what do we have? Well, there is a function a log e x minus b creates a graph, and that graph passes through 2 points, 210 and 820. And we are asked to find the values of a and b. So what do we know? Well, if we insert the values that we have in these two coordinates, we get a log e 2 minus b equals 10, and a log e 8 minus b equals 20. Now, someone might look at that and go, aha, there is an opportunity here for some form of simultaneous equation. Well, my pupil tried that with, I think, very limited success, and it has to be said that there was, I think, one error in the working, but when I tried it and compensated for that error, I still reached a point where it was going to be very, very difficult to proceed. So I thought to myself that probably what I should do is, instead of, I was using elimination, by the way, as was my pupil, in case I haven't said that. So what I thought I would try is some form of substitution. And this proved to be more successful. So let's have a look at what I did. So here's my first page of notes, and just let me talk you through these. Okay. So the first step was to isolate a, find a value of a in terms of b, and that's not hard. All we have to do is a little bit of algebra and we've got a on its own. Now I would make the note here that b can't equal 1, because if we have 2 minus 1, we get a 1 here, and the log e of 1 is 0. We don't want 0 on the bottom of an equation. What's my next step? Well, I sub in a to one or other of the original equation. So this expression here stands in for a, as I've pointed to here, and then I'm multiplying it by the second of these expressions. So my value of a here is now standing there, and that is what this expression looks like. Okay, so where to from there? Well, a little bit of rearranging. 10 log e of 8 minus b over log e of 2 minus b equals 20. Now just look at where I got that from. So I just multiplied through here, and so 10 log e of 8 minus b divided by log e of 2 minus b, which is what we've got here, equals 20. And then I just work through this in as systematic a way as I possibly can. And this, I'm the first to admit, took some thinking. The next thing I did was I multiplied both sides by this denominator here. Basically, I wanted to get rid of the denominator. So I take this expression here and I multiply it by this. I take 20 and I multiply it by this. And what I wind up with is this, of course, cancels out, and I wind up with a single line. So I can put a line through that. I get 10 log e 8 minus b equals 20 log e 2 minus b. Then what I did was I divided the whole thing by 10. So essentially I'm taking out this and most of this. And what I get is I get log e 8 minus b equals 2 log e 2 minus b. So where to from there? Well, this is where one of the many log rules comes into play, but one that I hope you'll be familiar with. Now, if I just push this page up a little bit, maybe a little bit more so I can get this in. The difference between this line and this line is simply that I have moved the 2 to here. So it is now log e 2 minus b squared. Okay, so let's continue. Well, we've got log e on both sides. So what we can do now is we can simply solve this. So we have 8 minus b equals b squared minus 4b plus 4. That's this squared. This is a perfect square. This is our outcome. Tidy that up, and we get b squared minus 3b minus 4 equals 0. Now there are two factors for this, b minus 4 and b plus 1. Now, that means that there are two possible solutions, I should say. b equals 4 or b equals -1. Now this is the one we want. Why? Because if we put 4 into this, we're going to have a negative number as the argument of our logarithm, and that we can't have. So 2 minus 1 will give us 1. That's okay. We can live with that. So b is -1. I have found b. After all that work, I have found b, I think. Right, so onwards. The next thing to do is to find a. And what I'm going to do to find a is go back to my original formulation of a and simply sub in b. b is the only thing that's missing here. Everything else here has a value. So I sub in b and I get a equals 10 on log e 2 minus -1, which with a little bit of tidying gives me 10 over log e 3. That is a. Now, I wasn't overly confident because I was doing this late at night, and I did find that it stretched the brain cells a little bit. So what I did was I did two checks. This is the first check, part 1. So I put my numbers to work. Essentially, I subbed in the values 2 and 10, and what I had found b and a to be. What do I get? Well, what happens is, surprise, surprise, 2 minus -1 is 3. I should put brackets around those. And what we find is that that and that cancels to 1. 10 times 1 equals 10. 10 equals 10. That's looking pretty good. Now, where do I go from there? Well, I try it again. I try the other values. 10 log e of 3 times log e of 8 minus -1, which is 9, equals 20. Now, I can't do exactly what I did up here, but let me show you what the way around that is. I rewrote that expression as this. So just to go back, I have this, and this is exactly the same expression, slightly rearranged. And I have 10 times this value equals 20. Now what does this equal? Well, surprise, surprise, it equals 2. It does not equal 3. It equals 2. And that's probably another video on log rules on its own. But you can put this into a calculator and check. You'll get 2. So there we have it. So what are our solutions? Well, A is this, and B, if you remember, is -1 for all the reasons that I outlined. So thank you very much for watching. I hope you found this useful, and if you did, please like and subscribe, and I'll see you next time. Bye.